Imagine you're walking through a forest, and suddenly, the trees start to whisper. They're not just trees anymore. They're part of an intricate, invisible web of energy and forces that you can't see but can feel. This web is not something from a fairy tale. It's the reality of our universe, a reality that Michael Faraday helped uncover. Faraday's discoveries, though they might seem abstract and complex, are actually the foundation of the technology we use every day, from the smartphones in our pockets to the satellites orbiting Earth. Let's dive into the story of how Faraday and his successors changed our understanding of the world, making it a place of endless wonder and mystery. Michael Faraday was a man of humble beginnings. He started as a bookbinder's apprentice and had little formal education. Yet his curiosity and passion for science led him to become one of the greatest experimental physicists of all time. Faraday's work was groundbreaking because he saw the world in a way that no one else had before. He realized that the forces of nature, like electricity and magnetism, were not just separate phenomena, but were interconnected in a way that could be described as a field. Faraday's early ideas about interparticulate strain were a bit like imagining a bunch of tiny strings pulling and pushing on each other. But he soon realized that this metaphor was too simple. Instead, he proposed a flood of power that filled the space around objects, creating what he called lines of force. These lines were not straight paths to the nearest pole, as earlier theories suggested. Instead, they were continuous curves, forming a web of energy that surrounded every object. This was a radical idea because it meant that the energy of a magnet, for example, wasn't just in the magnet itself. The energy was in the space around the magnet, in what we now call the magnetic field. This concept was the foundation of what we now know as field theory, which is crucial in modern physics. It's like saying that the power of a magnet isn't just in the magnet, but in the invisible force field that surrounds it, influencing everything nearby. Faraday's ideas were revolutionary, but they were also very hard to visualize. He needed a way to describe these fields mathematically, and that's where James Clerk Maxwell came in. Maxwell was a brilliant mathematician who took Faraday's ideas and turned them into equations. These equations, known as Maxwell's equations, described how electric and magnetic fields interact and how they can create waves of energy that travel through space. This was a huge leap forward because it allowed scientists to predict and understand the behavior of these fields in a precise way. Maxwell's equations were so powerful that they became the basis for much of modern physics. They explained how light travels, how radio waves work, and even how the universe itself is structured. Einstein, one of the greatest physicists of the 20th century, said that Maxwell's equations were as important as Newton's laws of motion. They were the key to understanding the unity of the forces of nature, just as Faraday had predicted. But the story doesn't end there. As scientists continued to explore the world at a microscopic level, they discovered even more mysteries. J. Thomson, a British physicist, discovered the electron, a tiny particle that is much smaller than an atom. This was a huge breakthrough because it showed that atoms, which were thought to be the smallest building blocks of matter, could be broken down even further. This discovery paved the way for the development of electronics and modern technology. Ernest Rutherford, another brilliant physicist, took the next step by discovering the atomic nucleus. He showed that the atom was not a solid sphere, but had a tiny dense core surrounded by a cloud of electrons. This was a shocking revelation because it meant that most of the atom was actually empty space. It was like finding out that a watermelon was mostly air with just a tiny seed in the middle. These discoveries led to the development of quantum mechanics, a branch of physics that deals with the behavior of particles at the smallest scales. Quantum mechanics is full of strange and counterintuitive ideas. For example, particles can be in more than one place at the same time, and they can instantaneously affect each other no matter how far apart they are. These ideas might seem bizarre, but they have been confirmed by experiments and are the basis for many modern technologies, from lasers to MRI machines. As scientists continued to explore the mysteries of the atom, they found that the limits of mathematics were being pushed to their breaking point. The equations that worked so well for describing the behavior of large objects, like planets and stars, didn't always work for describing the behavior of tiny particles. This led to the development of new mathematical tools and theories, such as the theory of relativity and quantum field theory. Einstein's theory of relativity, for example, showed that time and space are not separate and fixed, but are intertwined in a way that can be affected by the presence of matter and energy. This means that the way we experience time can change depending on how fast we are moving, or how close we are to a massive object like a black hole. It's a mind-bending idea, but it has been confirmed by experiments and is essential for understanding the universe. The journey from Faraday's early ideas to the modern theories of physics is a story of constant discovery and revelation. Each new discovery has opened up new questions and new mysteries, leading us to a deeper understanding of the world around us. From the invisible fields that surround us to the tiny particles that make up matter, the universe is a place of endless wonder and complexity. In the end, the most surprising thing about all of this is that we can understand it at all. The universe is a vast and complex place, but through the power of human curiosity and ingenuity, we have been able to uncover its secrets. As Einstein once said, the eternal mystery of the world is its comprehensibility. The fact that we can make sense of the world, even in its most mysterious and complex forms, is a testament to the human spirit and our never-ending quest for knowledge. So, the next time you use your smartphone or watch a satellite orbit the Earth, remember that these technologies are the result of a long and fascinating journey of discovery. From the invisible fields of Faraday to the tiny particles of quantum mechanics, the world is full of wonders waiting to be explored. And who knows, maybe you will be the one to make the next big discovery that changes our understanding of the universe.